My pleasure indeed to introduce our guest speaker today, Dr. John O'Shea. Dr. O'Shea is curator of the Great Lakes Archaeology at the Museum of Anthropological Archaeology, and that's located in the University of Michigan in Ann Arbor. Dr. O'Shea, in his studies, he has specialized in prehistoric archaeology, gaining a diploma from Oxford University and a PhD from Cambridge. Now, I first encountered John in 2015 while I was researching Lake Huron for my book, Heart of the Great Lakes. I found out that he had discovered 9,000-year-old remains of caribou hunting structures on the bed of Lake Huron. The question now is, how do you do prehistoric archaeology 100 feet underwater? Well, we're about to find out. The Bruce County Historical Society is pleased to welcome a groundbreaking scientist, Dr. John O'Shea.
Thank you, Robin. This talk for me today is a little different than normal because I've never really been asked to talk about how I got to where I am or to what I'm doing as a prelude to the work that we're doing. And so I'll show you that it was all pretty predestined. I grew up by the sea, and it's clear that I was destined to work on the water forever. The sea, if you're willing to accept the Permian Sea as a sea. I had a very direct route to get from Lincoln, Nebraska to Ann Arbor, Michigan, which included, as Robin noted, studying in England, a dissertation that didn't happen in Mexico, a dissertation that did happen in Bronze Age Hungary, a first teaching job in Amsterdam, and a teaching job at the University of Iowa before finally coming to the Great Lakes and Ann Arbor. And so what should be obvious from this career trajectory is that I arrived here knowing virtually nothing about the Great Lakes and was told, okay, now you're the curator of Great Lakes. At the very first Midwest Archaeological Conference that I went to, in the bar with Charles Cleland from Michigan State, I began to learn what every Great Lakes archaeologist needs to know about. And two of those really striking facts were, first, the existence of the lake effect, which is in Nebraska and I'd never heard of. But lake effect was very interesting because I was interested in prehistoric economics and agriculture. And it was immediately clear that lake effect and the extreme spatial variability in crop yields was going to be important in prehistory. This diagram here, this map, shows the distribution of Jutland phase sites, which are late woodland sites, which all clearly were focused both on the lake shores, but also within that kind of lake effect area. So this was very interesting to me. The second thing I learned about was about these changing lake levels and how they varied radically in the post-glacial period. And I basically wanted nothing to do with this. The idea that my research would be controlled by the changing opinions of geologists was utterly frightening. So I decided to take advantage of that first piece of information and began to work on the late prehistoric, the Jutland phase, late woodland, in and around Lake Huron primarily. My first work was around Hubbard Lake, which is in northeastern lower Michigan. And I got there advantageously before the major cottage developments happened. So many of these red dots you see on the map at the left, those sites probably no longer exist. But in doing this, then we spread out, and I had my initial introduction to the Lake Huron shore. As we started looking at the potential for navigation up and down the lake shore, looking at navigational markers. And I was so taken by it that I actually bought a property on the lake shore at Sauble Point. Then come around 1999, 2000, we had those very, very low water levels in Lake Huron, and we started having shipwrecks appearing on people's shores. The wreck on the left is the keelson and bilge of the schooner barge Mears, which sank November 27th, 1889. It's actually on our beach. The middle picture is a wreck in Harrisville Harbor. The one on the right is another wreck in Tawas Bay. So these wrecks were appearing, and at the same time they were appearing, we started to see this phenomena of people looting them to take the timber to sell as shipwreck wood for furniture making. And this just viscerally offended my sensibilities. And I decided I better document these wrecks. Now, one of the problems I face in doing archaeology is that in our household, you're not allowed to do anything that's simple or easy. So I can't study shipwrecks by diving on intact vessels and fanning off the name on the transom. I have to work on scattered wrecks that are hard to work on. So essentially, my shipwreck work began much more in the mode of an archaeologist than a historian. So we did the nearshore survey. As you see on the left, it went from Tawas, it goes all the way up to Alpena now, where we were essentially recording all the remnant wreckage of vessels, both in shallow water and on the beach. We documented them, and we even did such arcane things as documenting the density of coal distributed along the lakeshore. What you see on the right is a satellite image, actually, of a Sable Point, and you can see the distribution of coal. This coal is all coming from the steamer Baltimore, which sank offshore and was carrying a full load of coal. And what this illustrates is that even after 100+ years, the distribution is something as movable as coal is still quite indicative of where wrecks occurred and where they were located. Now, invariably, as you start working on these nearshore wrecks, you get drug into deeper water. Pretty soon you're having to deal with intact vessels. You're having to use various kinds of remote sensing techniques like side scan sonar or scanning sonar, but it was still treated as an archaeological problem. This figure on the right is a sketch of the steamer E.J. Leway, which sank up near Drummond Island. And the issue that I was there to solve was, did the scattering of the debris come about because of the ship hitting the bottom, or was it attributable to later ice flowing over the top? And I think if you contrast the blue arrows with the black arrows, you can see there's good argument that there was an initial collapse from impact on the bottom, and then the cabin and the superstructure was taken off later by ice. Now, the one other thing that happened while we were working on the Leway is that there were a series of divers that were working here. Those of you who dive know Lake Huron has wonderfully clear cold water. And at some point, the diver said, look, mate, if you're going to tell us what to do, you've got to get wet and cold too. And so at that point, I learned to scuba dive. And it was many years later in the Bahamas that I discovered I actually enjoyed diving rather than simply having diving as a piece of part of the working business. Now, the kind of background to this and what all this led up for me intellectually was a realization about this spurious present that the world we see around us right now, and I'm thinking particularly about things like lake levels, is really very incidental. If you take the Great Lakes, we can go inshore and find ancient lake shores. We have the near shore where my broken wrecks were, which also have fossil lake shores. And we also have deep water where the intact boats are. So where the water actually is at any given time isn't really all that important. And because of that, we can begin to speculate about this thing that I tried my best not to think about, which was what happens when these lake levels vary significantly, and particularly when they vary to levels where there's large exposed areas that are underwater, the so-called undiscovered country. This image was actually drawn by the artists at National Geographic as part of their Drain the Great Lakes show. Now, the Holocene Great Lakes, as you guys know, were very dynamic. You have the process of glacial meltwater filling these gouged basins of the lakes, and you have eustatic rebound, the land surface coming back up. And as a result, the lake levels go up and down. So you have Lake Algonquin in our part of the world, which is much higher than present. Then you have the Lake Stanley stage, which is much lower than modern day. And in fact, the figure on the right is by C.F. Lewis, and that blue line is his estimation of the actual levels of Lake Huron during the early Holocene. So it's quite a variable and dynamic environment. Now, if we look at the bathymetry of Lake Huron, you'll notice I've annotated a central area with dashed lines. That's the Alpena Amberley Ridge. First time I ever heard the name Amberley. And what it effectively did during Lake Stanley, which is about 100 meters lower than modern lake level, is you had a very deep lake, you had a shallow lake to the southwest of it, and then for much of the time, Georgian Bay was isolated as its own third lake. And so this is a time period we're looking at between about 10,000 and 7,500 years calibrated BC. Now, if we look at that landscape during Lake Stanley, you get an image that looks like this. And I should add, this is what I always refer to as my Canadian eye perspective, because you're north looking south on Lake Huron. You have Saginaw Bay on the right. Everything that's green is modern land. Everything that's brown was land that's underwater now, but that was available for occupation during Lake Stanley. And that's 260,000 square kilometers of land. The Alpena Amberley Ridge is the causeway that you see running diagonally through the middle there. So this is the area that was potentially available for occupation. The area that most archaeologists recognize should have archaeological sites, but I think everyone pretty much imagined that these sites were destroyed. They were either destroyed by the water or very, very deeply buried in coastal areas. And what our work has fundamentally demonstrated is that wasn't the case. I throw this in just because I've always wanted to find a use for it, and I think I finally did. But what we're really talking about now as we shift from shipwrecks to submerged site archaeology is a very different kind of paradigm, and particularly the environment and the nature of the lake bottom it exercises a very different role. That with shipwrecks, we typically know there was a boat, we know there was a boat lost, and all we've got to do is find it. And the background environment, what the bottom is like, is largely incidental to the wreck being present. Now, if we're going to look for ancient archaeological sites, we first of all don't know that the sites are there or not. They're going to be small, they're going to be difficult to locate. But what's going to be fundamental is the environment represented by the modern lake bottom, because that is what would have conditioned and shaped the native habitation to it. So we have to understand what that environment looked like 10,000 years ago before we can even hope to start looking for archaeological sites. Now, fortunately, the cold, clear waters of Lake Huron preserve a lot of good environmental data. And the image that has emerged from work by Lisa Sonnenberg and others on this submerged environment is one that's a little surprising. The Alpena Amberley Ridge remained a cold periglacial environment with sedges and marshes and open areas. And it didn't experience the kind of succession of fauna and vegetation that we see in mainland Ontario or Michigan. We don't see the closed forest, but instead you see something that looks very, very subarctic. This is a discovery that we made literally just this summer. We were going along and we saw a log sticking out from under some rock, which is that upper right-hand picture. The lower right-hand picture you see in closer, you can clearly see the log there. That log turns out to have human modification on it. And it turns out that rock wasn't really rock, but it's a thick layer of peat. And it's peat that extends over 1/2 kilometer on the seafloor. And it is loaded with environmental data. It has seeds, it has pollen, it has spores, and it's been dated to 9,700 years ago, as has the wood. So this is a very ancient deposit, but it's a gold mine in terms of modeling that local environment. And what should also stand out from here is there's no sediment on top of any of this. And that's because we're 50 to 60 miles offshore and no terrestrial sediment reaches here. So were it not for the invasive zebra and quagga mussels, this would be a Pompeii-like situation. You could see everything. You can still see things pretty well, but you don't have to excavate to get to the level of the archaeological phenomena. This is largely what the place would have looked like. It would have looked like kind of a spruce parkland, really flattened out from having glaciers over it. scattered spruce, lots of marshes, lots of water. Now, one of the things that has come along with this idea of it being and staying a subarctic environment is that it tended to act as a refugium. Now, when you hear refugium, people normally think of places in Alaska that stay ice-free during the glacial maximum. But this is a case where it's a refugium for cold-adapted species, plants and animals. And particularly animals such as caribou that were attracted to this, and the human technologies and hunting strategies that go with them were similarly preserved out here. This kind of illustrates how this refugium idea actually functioned. Ashley Lemke at the University of Texas plotted all of the paleontological caribou finds that have been dated in Michigan. And there's a surprising correlation where the caribou finds are reasonably plentiful during times of high water, and they're entirely absent during the Lake Stanley phase. And the logical implication of this is the caribou are somewhere else, and that somewhere else is out on the lake floor. Speaking of caribou, caribou are a surprisingly fascinating animal for many, many reasons, but a particular reason is that they have a tendency to be attracted and follow lines. This was first noticed in North America, I guess, modern North America, when they put in the Arctic pipelines, which diverted hundreds of thousands of caribou migrations. The Ambler Road up in Alaska now is doing the same thing. Now, it turns out that the reindeer herders in Siberia and in Lapland were very well aware of this tendency, and they actually used it as a way of herding these semi-domesticated reindeer. You can see here too, even when the animals are migrating, they tend to migrate in these linear features. And in fact, the very trackways that they make tend to produce reinforcing walkways. So the animals tend to move in these lines, they tend to follow lines, they tend to be attracted to lines. Now, not surprisingly, hunters are aware of this as well. And we have good ethnographic models from many parts of the world that show how hunters use drive lines, various kinds of snares and traps to direct caribou, migrating caribou, particularly into kill areas. And as you can see here. Now, here's an example. This is from Victoria Island in Nunavut. And this long black curving line you see is the Edgington site, which is a large drive lane. There are a couple smaller drive lanes next to it. Now, if you look at this on the ground, that's the Edgington drive lane. I mean, if you didn't know it was something, you might wonder if it was anything at all. In the foreground, you actually have a hunting blind that's been used recently. You see the remains of a fireplace there. So the deal with these caribou drive lanes is they're not trapping the animals. It's not like the bison kills out west where panicked animals are stampeded over a cliff, but rather they just gently follow these lines into kind of kill areas. And so that's kind of what we're looking for. So if we're going to look for these sites underwater, we've actually got three things working with us. We have the bathymetry that shows the kind of narrow path where these animals would have migrated. We understand how hunters went about trying to hunt caribou, particularly on the migration. And we have a good sense that the way these hunting features are going to be constructed out of stone are actually going to be visible to our acoustic search techniques. So we actually had some advantages going into this work. If you look at this, you can see the three primary areas where our work has been concentrated. Area 2 is actually the deepest part, and it's the area we've worked in the least, primarily because that's right on the main shipping channel, and it's very difficult to anchor in place there. Area 1 and 3, though, are where we've worked intensively, and just this summer, we've done new multi-beam survey that basically links that coverage together. So we're looking at the very central part of the Alpena Amberley Ridge. Now, I was going to show you this, but I think maybe for reasons of time, I'll skip it, what the bottom looks like, and rather just show you some of the examples of what we found and how they compare with equivalent examples on land. So here's an example of drive lanes. Here's a couple more of those on Victoria Island on the left. And you can see a large one there on Lake Huron on the right. Sometimes instead of continuous stone lines, you have lines of Inukshuk. This on the left is from the Kazan River that Andrew Stewart documented. We have a similar line of them in Lake Huron. You can actually see our ROV cable has snagged this one. We find hunting blinds, often this V structure with five stones, large boulders. Each of those boulders is probably about 1 meter in diameter, facing in the direction the animals are moving from. Here on the left, you have the remains of structures, again on Kazan River, and on the right, the equivalent at Lake Huron. And here are cache sites and small shelter sites, temporary campsites. The one on the left is the Dragon Blind, which turns out to be very important. It's had, actually, we've done some excavation there. It has considerable amounts of material. This is the same blind. This is the state archaeologist Wayne Lasardi scraping away. And one of the surprises is when you take the dead algae off the top, all of these main stones are old red sandstone boulders off the Canadian Shield. Now, they're brought down by the glaciers, obviously, but there may be some sense that the hunters were actively selecting this color. This thing also produced a cervid, fragment of a cervid tooth. It's too small to be ID'd, definitely, but it's very probably caribou. We also find more complex kinds of hunting features. This is the funnel blind. Here you're looking at a scanning sonar image, which is kind of doing a 360 around, showing you the different pieces. Here's another view of this same blind that you can see how it creates kind of a funnel shape and how little else there is around it. Now, this is, and it's a little fuzzy because this is actually from a photogrammetry model. If I was a little more sophisticated, I'd be doing the 3D for you right now. Anyhow, I'm going to show you a short video now to give you an idea of both what the water looks like underwater, the amazing visibility we have, but also an idea of what that hunting structure looked like and what have you. Oh, excuse me, let's try this. This imagery is shot simply with a GoPro, and it's all shot with natural light. So you have really amazing visibility here. Here's one of the stone lines, and you see it there. It's actually located on a cliff where it falls off behind it. And there's more concealment below it. Now the diver is swimming towards the focus point of the funnel. You can see our ROV over there on the left. It's Jake. He has a Facebook page. But the thing that's striking about this is not only that you have this interesting alignment of stones, but there's nothing else out here. That it's just pretty much empty limestone surface, except for these boulders that have been very consciously positioned. I think that's probably enough of that. This is another one of the complex hunting structures we found. This is known as Drop 45. This is again a scanning image, and you can see, I think, right on the right to center, you can see the lane that's been created. Here's a schematic of the same deal where you have the pavement on the left, you have a line on the right, the animals are kind of taken through it, and then they come into this natural cul-de-sac or kill zone. Now, one of the things that's significant about these more complex blinds and hunting structures is they would have taken a lot more people to actually run them. You've got the different hunting blinds, you presumably have people waiting in the back in the kill area. You presumably have other people, perhaps women and children, outside helping to kind of channel the animals towards the structure, but definitely more complicated. And it turns out that their location is actually very specific. So that's kind of what we've seen. Let's try to put it into some kind of context. And this is sort of just an aside, but one of the things we did as part of our predictive modeling is we created an immersive virtual world model of the Alpena Ridge as dry land, as it would have appeared at the time it was used. And we started out with this as a method of site discovery. And in fact, we took it up to Alaska. This is a traditional hunter who is basically hunting on this 10,000-year landscape. But we're using their insights to improve the accuracy and to understand kind of where the sites are located. It now is developed and taken a life of its own, and it's being incorporated into school curricula now. We're hoping to link school students in Alpena with school students in Kotzebue to collaborate on caribou hunting. But anyhow, putting in context, what we basically know is that there are different kinds of hunting structures. There are these simple ones, these V-like ones, and then there are complicated ones. And the complicated ones clearly take more people to run. We also noticed that many of these hunting blinds and features only work if the animals are moving in one direction. Now, this is critical because this is the key to understanding the season of hunting. Typically archaeologists use animal teeth as a way of working out seasonality, but as you know, in the Northeast here, the acid forest soils do not preserve bone only rarely. So this was a unique way of understanding the direction the animals were moving, what season they were moving in, that we could then assign the different hunting structures. One result of our simulation work has also been to suggest that the pattern of seasonal movement of the animals themselves differed in the autumn and in the spring, as you can see here, that the autumn migration south tended to be a lot more lackadaisical, a lot more grazing, browsing going on. The trip north is much more, let's get there and go. And yet, despite that, all of these migration patterns have certain choke points where all the different routes come together. And as you see on this diagram, one of those is where that drop 45 drive lane is located. Another is in the southeast corner of the map. And it's not coincidental, I think, that the big and complex hunting structures tend to be the ones that are located in these naturally occurring choke points. We've also have enough of a sense now to know kind of what the whole seasonal round is starting to look like. And this is interesting because it is somewhat different than you might expect from modern historical parallels. During that fall migration, it appears you have relatively small groups of hunters, small bands, maybe multiple families, going out using these smaller hunting structures, harvesting the animals and caching the meat. So we actually find meat caches. Fall is traditionally when caribou hunting is preferred because the animals are in the best condition, the sinews are in good condition. In the winter, I suspect nobody lived on the Alpena Amberley Ridge. We think people probably went back to the tree line on the mainland, but they did make logistical forays elsewhere, and they probably did cross that frozen inner lake to get to those caches out there. In spring, we see people kind of emerging from that hungry winter and coming to these large, complicated hunting structures where they are mass harvesting animals as they migrate. It looks like you have a lot of people there. It takes a lot of people to run these hunting structures. And there's no evidence at all that the meat is being cached. So it looks like people are hanging around, consuming the meat, and then they move off to summer. And I have to admit, summer is the time we have the least evidence of right now, although we're starting to collect some evidence that suggests an exploitation of aquatic resources, perhaps even the beginning of net fishing in the summer. Now, speaking of winter on the AAR, the upper left is the artist's rendition of what this looks like. The bottom right is a photo I took from a float plane up near Kotzebue on the Baldwin Peninsula of Alaska in March. And I would wager that we're looking at basically a picture of the same thing. A narrow causeway, water on both sides, bitter winds. I'm suspecting not a very attractive place to want to live. Okay, I've been telling you about hunting structures. I've been telling you about a reconstructed environment. And I'm sure the question that is in your mind is, well, if we're talking 10,000 years ago, where are the fluted points? Where are the artifacts that really are the gold standard to convincing us that these are real things and not just natural accidents? And the answer is given to us by none other than
you humans. When are you going to learn that size doesn't matter? Just because something's important doesn't mean it's not very, very small.
Yeah, I always like to use that too. In fact, what we have found is that we have not found bifaces. We have not, although there's some occasional flakes, but the stone tool industry rather is a kind of micro tool lithic industry comprised of very small unifacial tools and small microblades that were then being hafted into composite artifacts. There's a lot of emphasis on bipolar reduction too, because they're basically using scavenged glacial cobbles for their raw material. Now, the interesting thing about micro tool industries is they are common throughout the globe in the early Holocene. And they're often seen as reflecting high mobility and low predictability of raw material availability. And that's exactly what we see on the Alpina Amberley Ridge. In fact, the question might be, the large bifaces are perhaps more unusual here than the micro tool traditions. Among these micro tools is a little thumbnail scraper here. This one is important because it's fashioned on Bayport chert. Bayport chert comes from down in the Saginaw Bay around Charity Island area. So this raw material was brought north at least 100 kilometers. Here's an example of one of these microblades. Again, look at the scale. It's 2 millimeters is our scale there. But even though it's so small, you have edge damage on the tip. You have micro retouch on the side. And use wear work that's been done on this shows traces both of use, but also the wear from hafting, where these small blades are being set into a bone or antler shaft. More small tools coming from the Alpina Amberley Ridge are these 2 flakes of obsidian. Now, obsidian is incredibly rare in this part of the world until the Middle Woodland period. And these pieces of obsidian, using both neutron activation and X-light fluorescence, have been traced to the Weigand tire outcrop in Central Oregon. So somehow, some way, our guys out in Lake Huron were using obsidian that came from the West Coast. And this is actually the farthest west that any of these specific obsidians have been found in an actual dated archaeological context. Also tantalizing, and these come actually from that cache site, the Dragon Cache, are the beginnings of what may be ground stone tools, which we normally think of as being something that's kind of late Archaic in age. We've got a net sinker in the middle, a small hafted axe on the left, and a quartzite chopper on the right. So at the end of the day, what we're left with is a unique combination of elements. We've got these hunting structures, we've got this micro tool industry, we've got bone antler tools, we've got the precocious appearance of groundstone artifacts, none of which are known from this time period on the mainland in Ontario or Michigan. And they have their greatest similarities with small tool traditions in the Arctic, which leads us to what has been called the kind of ice front hypothesis. And this hypothesis takes as its starting point the ecological fact that the ice front, the area adjacent to the ice front, is actually a very rich environmental zone. Very rich in plant life, would have been very attractive to animals, would have been very attractive to hunters. And as the Laurentian ice sheet is withdrawing, you're exposing this new land, this recently deglaciated land. And we believe that this is kind of the corridor in which these hunters using these small tool traditions are operating. The recent report of another small tool tradition series of sites has come out of southern Alberta and British Columbia with the same age as our sites in Lake Huron. So it does lend some support to the idea that there was a similar kind of adaptation along this ice front. It may have actually facilitated the movement of people and materials as well and helped to account for the obsidian. So the other question I guess that often people will have is why only underwater? And I think there are a couple of reasons. One is that the cold, clear waters of Lake Huron preserve categories of evidence that just don't exist on land. I'm thinking of bone, I'm thinking occasionally of bone, but certainly wood. And these hunting structures that the first time a farmer got in the field, those hunting structures would be over on the fence line. Because Lake Stanley occurred only in a relatively limited time and the water never returned to that lake level, we also have a very narrow chronological window. So all the archaeological constructions that we see on the Alpena Amberley Ridge have to date to that time period. And finally, by virtue of the fact that we are working underwater, we have fine-grained recovery techniques. Obviously, we're water screening. The material that are recovered from the lake floor are sorted in the lab under a magnifying glass or microscope, all of which tends to let us discover these very small artifacts that might well be lost by the guy with his quarter-inch shaker screen out in the field. Our sampling is also focused on known cultural features, these hunting structures, which lets us not only recover these small tools, but actually have a relatively good yield when we do, compared to normal terrestrial sampling, normal shovel testing. So I think that's why underwater. And I think the next step for us is to move away from focusing on hunting structures, which actually seem now to be pretty easy for us to find, but to look for things like habitation sites, which will have a greater range of cultural materials associated with them, and to start looking more in detail for those other seasons, particularly what were people doing in the summer. And again, I suspect some of these net sinkers and other features we're beginning to find may be leading us in that direction. So that's kind of the state of play as of now. Here's a word to our sponsors. I'm grateful for you all sitting through this, and I'll be happy to answer any questions you guys may have.
Okay, thank you, John. What we're going to do is ask you, if you have any questions, to use the chat feature at the bottom of your screen to type out a question. Dan Weigand will gather the questions up and ask John the various questions. So if you have any questions, please use the chat feature at the bottom of your screen.
Okay, John, Angus has a question. What does AAR stand for?
It stands for the Alpena Amberley Ridge. And again, it first appeared on that bathymetry map, I think, and we just start using the abbreviation because it's so long to say out.
Yeah, absolutely. I have a very pedestrian question for you, John. All this time that you've spent underwater, what's the most exotic marine life you've come across? Some gigantic sturgeon or something like that?
It was actually a very, very large and I think hibernating burbot that emerged out of the bottom, out from under a log, and it literally looked like the Midgard serpent kind of coming out of the center of the earth. It was clearly annoyed at being disturbed, but it was moving pretty slow because it was just waking up. It was, and they're bizarre looking fish if you've ever seen one.
Wow. Okay, thanks, John. Question from Marvin, and it just moved up on me, sorry. I was wondering if any bones were found underwater on the ridge, especially bones with embedded micro tools.
To date, the actual embedded tools have not been found. The one problem we have, which is similar to terrestrial archaeology, is there's a period when this landform is going underwater, when you have basically spruce trees near the water level, and it creates a very acidic environment. In fact, it eats up the limestone. So the only time we find bone is when it is in a feature of some kind. So we've remarkably found fish bone, but it's fish bone within a terrestrial feature under a lake. We found the cervid tooth. We found burned bone will survive, but we've yet to find that hafted tool.
Okay, thanks, John. Nancy has a question. We often find what we believe to be fossils on the beach near Amberley. What should she be looking for that relates to the ridge or might relate to the ridge?
Well, that's a real good question. The small kind of tools we're dealing with probably wouldn't transport to over there. So what you'd probably be looking for is the normal kind of archaeological material you'd find on land. That would be because that would be the source it'd be coming from. It wouldn't be coming from out in the middle of the lake. Now, I should add that we have never crossed the national boundary. So there's a whole half of the Alpena Amberley Ridge on your side that, to my knowledge, has never been looked at.
Oh, wow.
And so there's a lot to be found out there.
Which relates really well to this next question from Robin. What are the chances of underwater finds on the eastern shore of Lake Huron, say off the shore of Bruce County? And you've already addressed that, yeah.
Absolutely. And that the channel, I forget the name, between the end of the Bruce Peninsula and Manitoulin Island, I think has already produced, submerged landscapes and rooted trees and other stuff. I don't know if they found cultural artifacts there yet, but yeah, there are these landforms. When you put the lake down 100 meters, there is a lot of habitable land on both sides of the lake. And on your side, you've got that deeper cold water lake. Which actually, one thing I'm hoping still to investigate is that cliff there drops from about 40 feet in depth to over 500 feet in a very short distance. And I'm absolutely positive that at the bottom of that cliff, there could be anything. There could be a whole elephant sitting down there because it would have been washed off the edge during the big flood. And at that depth, it would never have been moved again. So I've been trying to get Greg Bush and his yellow submarine to go over there and go down and look there.
So many interesting discoveries related to the peninsula. 1,1300-year-old cedar trees on the cliffs, discovered by Doug Larson, University of Guelph, and his crew. Okay, Jenna has a question. Actually, sorry, you should go to Janet first. I think you've already addressed this. Have you looked at land bridges like the one between the Saugeen or Bruce Peninsula and Manitoulin Island? And you said you haven't really crossed over into Canadian territory. Jenna has a question. Thanks, John. Great presentation. I would concur, absolutely. Would these sites have any relationships to, and I will not get this pronunciation correct, Shigwinda? Have there been any white quartzite artifacts?
Yes, that's an excellent question, actually, because the dating of Shigwinda is contemporary with our stuff on the Alpena Amberley Ridge. And Shigwinda is a very interesting site because, as is alluded to, they have this white quartzite, George Lake quartzite, I think they call it, up there, that was being used for tools. And in fact, there are a subset of the tools that Patrick Julig has worked on that are actually microblades. So we're very interested in those potential connections. One of the things that's made difficult with this is any raw material that's north of us is potentially transported by glaciers. So we have to say, okay, did people procure this, or was this simply in the fill, or and people picked it up? That's why things like from the south, like the Bayport chert was exciting for us, because there's no natural process that could have brought it north. There's Norwood chert on the other side of Michigan that's turning up on some of these early sites. And again, there's no way it could come from anywhere else. But no, the Shigwinda connection is a primary interest to us. And in fact, we've been talking extensively with Patrick up there about how we might link them together.
Excellent. Are there any further questions to our assembled group. Okay, Ron has a question. How wide is the AAR?
It varies a bit, but where we're working, it's a mile or two max in terms of what's above ground, maybe a couple miles. And this is actually really important. You know, if you read the historical accounts of caribou hunting, like in the late 19th century in the Arctic, people can never find the animals. They're always looking, everybody's asking, have you seen them? And if you don't find them, your family starves. So finding them was a big deal. Here, the movement of the animals is much more predictable because they have to pass through that corridor. A certain number have to pass through that corridor. And so I think economically, from the point of the hunters, this is a great place. And this would have made all the trouble working out there worth it. And actually, one of the things that's been growing out of this, we've been thinking of, there's been some additional research thinking about the origins of private ownership. And, you know, among hunter-gatherers, this is kind of controversial, but we know with salmon runs on the Columbia River and other places like this, that particular families or clans actually did own the apparatus, you know, the hunting weir, the fishing weirs or things. And there's some suggestion from Andrew Stewart's work that this was happening this way with caribou hunters on the Kazan River, that certain families were building structures and basically owned them. What's neat about the Alpena Amberley Ridge is even if the prime places are taken, you're still going to be able to get animals because it is this kind of narrow choke point you've got to pass through.
Excellent. Anne asks, would the people have possibly hunted woolly mammoths on the AAR at one period of time?
I don't think so. And that's based in large part on the kind of ecology of the different species. I think mammoths probably not. There were still clearly mammoths around at 10,000 years ago for sure. I doubt they're out where we are.
Okay, you've absolutely piqued the interest of this crowd. Nancy's asking, could you suggest any reading material on the AAR?
Well, we've published some. The university, we published a symposium in 2015 in the Museum Memoirs series in Ann Arbor, where actually Pat Julig, Andrew Stewart, a number of geologists and archaeologists and ethnographers all kind of thought about this problem. What should be out there? What should we be looking for? We do have a website at the museum. I'll have to get the address to you because I can never remember it. But it has both some information on its own. It has references. It also has links to some of the different videos and things that have been produced about the work.
Fantastic. Thank you for answering those questions. And even as a transplanted Michigander, I know that you're looking forward to watching this football game between the Wolverines and the Spartans, which is at halftime at the moment, but I won't spoil it for you and tell what the score is. On behalf of the Bruce County Historical Society and its assembled online guests, I would like to thank Dr. John O'Shea for this incredibly interesting presentation. I remember the days years ago when I was driving to work and heard on the local radio station about your team finding these ancient structures at the bottom of Lake Huron and the exciting conversations we had at school. And I was a teacher then, not a student, of course. We look forward to hosting you in Bruce County, we hope, fingers crossed, next summer to make an in-person presentation of these findings. We know it will be well attended as many in the Point Clark area, so the southern end near Amberley. The residents and cottagers will certainly want to hear this presentation. And we especially thank you for donating your time with us today and your commitment for being with us online. And throughout this presentation, I was reminded of how much I enjoy an intellectual presentation and miss an academic's sense of humor from back in my own university days. And once again, thank you, Dr. O'Shea.
Well, it was a pleasure. Thanks for having me.
Thank you so much.